Vanakkam. Now we are going to solve problem number 3.4 from Digital Design by Moris Mano's 5th edition. This is simplification of Boolean function using 4 variable K-map. In this we have already solved this A problem, B problem and the C problem. So now we are going to solve problems D, E and F. Okay. So let's get started. So the function is given as f of w comma x comma y comma z. This is D problem. Okay, that is equal to summation of the minterms 2, 3, 12, 13, 14, comma 15. So we have to place the ones corresponding to this minterms. Okay, so for this 2 we are placing a 1, then for this 3, then 12, 13. So we have to place ones into the corresponding cells, then 14 and 15. So now we have to group them. So we can group this 4 number of ones first and we name it as loop 1, and the second loop can be formed by combining these two ones, that is the cells 2 and 3 can be combined and we can name it as loop 2. So now for this we can write the expressions. So for loop 1, this W and X are covered along this row wise, and this column wise these 4 columns are covered. So they get cancelled anyhow, right? So the answer is Wx for this loop 1. Then for loop 2, so it covers W dash X dash along row wise, and column wise it covers these two, right? So in this Z dash and Z get cancelled and Y is redundant, so only one Y can be returned. So this is the answer for this loop 2. Okay, and so the F simplified can be written as F simplified is equal to this Wx plus W dash X dash Y. So this is the answer. One more thing I want to introduce to you is these simplified expressions can be called as prime implicants. So this is Pi1, this is Pi2. What is Pi? Pi is prime implicant. So here we have two prime implicants. If the minterm in a particular group or loop is covered only once, then that can be taken as a essential prime implicant. This is also coming as EPI1. What is EPI? EPI is essential prime implicant. So this is also coming as essential prime implicant. So in all problems which are following from now onwards, I am going to give you these details also. Okay, but anyhow in the problem you are asked to simplify. Okay, so this is your answer. Now we move on to the next problem. So in the next problem we are given the function f of w comma x comma y comma z, that is equal to summation of the minterms 11, 12, 13, 14 and 15. So we have to place ones corresponding to this minterms given in the problem. So it is 11, you have to place a 1, 11, then 12, then 13, then 14 and 15. So now we are going to form the loops for this. So these 4 ones can be covered as a loop. So we name it as loop 1, and then we can cover these 2 ones as loop 2, that is the ones placed at cells 11 and 15. So it can be called as loop 2. Now we can write the simplified expression for loop 1 and 2. So for loop 1, row wise it covers Wx, column wise it covers all these 4. So it will be 1. So the answer for this one is Wx. So this is one Pi, prime implicant. And then we go for loop 2. So loop 2 covers row wise these 2. In this x and x dash get cancelled, so one w can be cancelled because it is redundant, so you get w. And column wise it covers this y is it only. Okay, so we have to write it y is it. So this is the answer for loop 2. So this is another Pi. So this is Pi2, and already we got one, that is PI1. PI is what? It is prime implicant. These prime implicants are essential prime implicants also. EPI1 and we get EPI2. These are essential prime implicants. So now the simplified expression is F simplified is equal to this loop 1 expression Wx plus the loop 2 expression Wyz. So if you want, you can take this W outside, then you can write it as X plus Yz. So this is your answer. Now we move on to the next problem, that is F problem. It is F of W comma X comma Y comma Z is equal to summation of the minterms 8, 10, 12, 13 and 14. So for that corresponding minterms we have to place a 1, isn't it? So for 8 you place a 1, and for 10 you can place a 1 into the cell, then 12th cell there you place a 1, then 13 and then 14. So this is how you can place a 1, right? And then we can form the group. So these 4 can be combined, that is 8, 12 and here 10 and 14. They can be combined and form a loop, and now we name it as loop 1. Then we can go for loop 2, and it can be formed by combining these two ones, that is cell number 12 and 13, and it can be named as loop 2. So now we can write the expression for this loop 1 and loop 2. So for loop 1 it covers on this side Wx and Wx dash, so you can cancel out these two, and W is redundant, so one time you can, it is W. Column wise, if you see it covers these two, so there this Y dash and Y can be cancelled, and this Z dash is redundant, so one Z dash is enough. Then when you go for this loop 2, loop 2 covers this 12th and 13th cell. Corresponding to that, on row wise we have this Wx. Column wise, if you see, it covers these two, right? That is Y dash is Z dash and Y dash is Z. So these two get cancelled and this Y dash is redundant, so you'll get it. So this is for loop 2 and this is for loop 1 expression. Okay, and we can call this 2 as PI. So this is PI1 and this is PI2, and both are essential also. So they are EPI2, essential prime implicant. So now we can write the F simplified for this as F simplified is equal to WZ dash plus WXY dash. So here also the W is common for both. You can take it outside and you can write it as Z dash plus XY dash plus XY dash. So this is our answer. Okay, that's all for this 3.4 problem. Thank you. Thank you.